All right, guys. So this is a 3 point or third or 11.3 problem. That's the kind of problem it is we have here. And this one's going to be a little longer because we have this part B here. That's not something I'm necessarily going to grade you on, but I figured I'd do it in the toughest of these problems, so it'll help you out. I don't know if any of the other homework problems have this in particular, but let's get going. So we have migraine and acupuncture. A migraine is a very particularly painful type of headache. Patients sometimes wish to treat with acupuncture. Hopefully, you guys haven't experienced migraines before. I hear they're pretty bad. Acupuncture, a little scary for me, but we shall keep going. We want to determine whether acupuncture relieves migraine pain. Researchers conducted a randomized controlled study. We had 163 patients, right? That's what our N is. Diagnosed with migraine headaches were randomly assigned to one of two groups, treatment or control. So those who, I guess, got the acupuncture and those who didn't get acupuncture, right? So there's 83 here, 84 there. 24 hours after patients receive acupuncture, they were asked to see if they were pain-free. So we have a group of people who got the acupuncture, a group of people that didn't get the acupuncture, and then after 24 hours, did they still have pain or did they not have pain anymore, right? That's the idea. We want to see if having acupuncture versus being paid free is independent here, right? So what are the two categories? We have P here is acupuncture, if I can spell this right. Wow, that's even worse than what I've written the other time. So acupuncture versus, we'll say maybe pain relief here, relief, right? We have an acupuncture and pain relief. We want to see if acupuncture is something that induces pain relief. So is there an independence between these two? So what is the correct null hypothesis in this case? Well, the way we always do it is we always assume things are independent. So pain relief is independent on whether you have acupuncture or not. So we're going to pick that one like that. And also, this doesn't do the requirements, so I'll do the requirements for us as well. The requirements, can I get to here? Requirements is we need simple random sample, which we can always either assume or whatever, so we're just going to check that out. We need two categories, which that's definitely what we have here. We have the category of people receiving acupuncture and the category of whether people have pain relief or not, right? So that's good. And we need each entry greater than or equal to 5 here. Um, I might have said greater than 5 in real life or something like that, but greater than or equal to 5 is fine. They're all in that case. Oh no. Oh my gosh, they are not in that case. So we're going to continue this as normal, but this actually fails the requirements I am giving for this class here. So that's a big boo-boo. So I would actually say yes. I'll say no, we can't do that, but we continue anyways. Anyways. Right. So we have formulas, just making sure. Yeah, that's definitely correct. We have formulas for finding this, and this is something that you don't necessarily have to do on the exam, but I'm going to show how to do it anyways. In general, how do you find the expected value of something? We showed how to find this formula in class, but the expected value is, I'll put E for each value is your row total times your column total divided by your sample size, which is n here. So we can have a row total, we can have a column total like this. The totals are actually already constructed for us, which is super nice. We can find that by these values here. So for this treatment, we have the row total, we have a column total, and we have the sample size, right? So it would be the row total is 80. Sorry, I kind of mixed that up. The row total is 80. The column total is 23. The sample size is 163. So this is 11 point, we're rounding at two decimal places, 11.29 here. Okay, For the next one, let's do this one now. Maybe I'll switch colors. Why not? We have a row total, which is 80, a column total, which is 140, and a sample size, which is 160. So now let's do row total of 80, column total of 140, divided by 163 here. So that's 68.71. Um, Now for the control side, we have a row total, which is 83. We got a row total, which is 83, a column total, which is 23. So 83, 23 divided by 163. So that's 11.71, another 11.71. Very interesting. And now we'll do this last one. So this is column two, row two. So column two is 140, row two is 83. So 83 times 140. 83 times 140 divided by 163, which is the total, right? Sample size. So that's 71.2829. Excuse me. So just making sure. Yeah. So we're rounding two decimal places, so we're fine with that. Find the test statistic, round your answer to at least 3 decimal places. So now I'm gonna erase some stuff here. Let's erase this so this looks a little bit cleaner for us, right? Let's round to 3 decimal places. So what we're doing, we're testing for independence, right? We have a calculator for testing for independence, right? Test for independence. Oh, isn't that great? So we just want to create this entire column, how this is. Be a little careful here because this has the totals. We don't want the totals. We just want the actual data. So 61, 4, and 79. Note that this is the real table here, just these, not the 80, but those 4 values there. That's those within the 2 categories, right? And your calculator, this calculator, actually is testing against these values we found individually and seeing is there a significant difference, right? The formula that finds whether there's significant difference becomes they add it all up to get that chi-squared. The larger that value is, the less likely this is actually what is expected to happen, right? So we got a test statistic, yeah, it's looking right, of 12.0 5, I guess. No, we're rounding to 3 decimal places, so 12.046 we'll do. What is the p-value? Round to at least 3 decimal places. 0.0005. That's at least 3 decimal places. What is the correct conclusion? Well, we test this against an alpha of, use alpha equals 0.01. This p-value is smaller than 0.01, so we reject the null hypothesis. The alternative hypothesis is that there is a dependence, right? This would be like your HA here. We reject the null hypothesis. There's statistical evidence that migraine pain relief is dependent on receiving acupuncture. Acupuncture. I said acupuncture. Oh, goodness. I think acupuncture, I can't say it. So I'll just leave it at that and click submit here. And let's see. Yeah, looks like we got it all right. Remember to do the PRTC still. This is the T, all this work here. You don't have to do this on the exam, but it's good to know that we can do all this stuff here. And thanks for watching.